In this video, I'll show you how you can be able to draw your graph given properties like this. So the first thing that you have to do is to check your properties and your restrictions, then you plan around your Cartesian plane, which is something that I've already done. Then you go and check which one could be your starting point or the easiest point to start with. Basically, it would be the one for this table, because the values are just like simple to plot. They're saying when you have your x minus 1, you will have your y is 0. That means now you can go and plot this one. Then when you have your 0, then your y would be 1 here, then it means your 1 will be here. Then when you have your 1, your y would be 4. Then you can plot this one here. Then your 2, you're gonna go to your 6, your y would be your 6. Then your 3, you go back to your 0. So now we are done with this first one. So now we're going to the top ones. The top ones, I also like to group them together, because you see these top ones, or these two ones, they are first derivative, and this second one, this second derivative. So the difference between these two is that your first derivative, this one, they would normally be just talking about where the graph is increasing or decreasing. Then this one, they talk more about your concavity of the graph. So you can have what we call it's your concave down. Then we can also have your concave up, just like in the previous video where I said I like to at least split this into two, so that you know that you can actually have two concave down graphs. You can have concave down that is increasing, which is in this region, and this region it's decreasing. Then you can have concave up, this region is decreasing, this region is increasing. You see? So that's basically with this part, or the part where you see that you have your second derivative to work with. So now they're saying, let's just check this one. They're saying your graph is going to be increasing where, in which region? In the region where your x is less than 2. Where is my x less than 2? Is from this region going that side. And another thing that I like to check that, okay, when I'm looking at my restriction, I can see that like 2, 2 to 1 comes as often. So I could just like go to my graph and write dotted lines like this. So I will know what is happening here, 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 and like in this instance, now I know from x being less than 2, which is from here going there, I will know that it's going to be increasing. Or I can just like write it as positive. Then for this one, they're saying it's going to be decreasing in which region? Between this region going that side where x is being greater than 2. You see? So now I already know that since it's decreasing, if it's decreasing, then I can just like simply just even write it now that okay, it's decreasing. It's going to be something like that, which is going down. So it means now I'm done with this point. Then now they're saying what they're saying, it is increasing where? In this region going there for in the meantime. So we're just gonna pause on that and also check the other points so that we don't miss anything, because now we're just interpreting it as if like we're going to be having something like this which is increasing, but we still need to consider these other 2 points that we're going to be working with. So now we go and check on these ones that, okay, they're saying between 0 and 1, between 0 and 1 it is going to be concave up. Concave up, it's like this. Then between, in the region where you're having your x is less than 0, so x is less than 0, we have our 0 here to that side. They're saying it's going to be concave down. Concave down is something that looks like this. And also in a region where our x's are greater than 1, they've given this one and this one. It means it must be taking on this shape, you see. So if it's taking on this shape like this, oh yeah, it's here, it's concave down like this. So it means between x is greater than 1, it means from this side going there, from going to 2 and forward. But like we've already worked that part, so it means now we're going to be having what? We're going to be having something that looks like this, see. So we've done this one here. Then they're saying where x is less than 0, x is less than 0 between this. So on this one we can also just like pause on it for now. So we're going to check, they're saying in the region between your 0 and 1, your 0 and 1. So what are we going to have in this region? They're saying it's going to be concave up. Concave up is something that looks like this. So it means if I'm having concave up like this, I'm just going to be taking this portion. So I'm going to be having something that looks like that. I'm going to be having something that looks like that. So this one I've done it, this one I've done it. Then there we're saying x is going to be, okay, this one we're still within that range. Then now they're saying we can go to the last one, which is it still has to be concave down in this region. So we can say, let me see, let me see, see if I didn't miss anything. This side, this side, this side, this side. Oh yeah, so now it's just a matter of just having to draw something that will look, can just connect this point to that, like this. So remember, they're saying where you're having your x less than 0, it's going to be concave down. My concave down, it's a shape that looks like this. This is exactly what I've drawn within that line. So now we go back and interpret the thingy again, just to make sure that we did the correct things. So we're having something that's, but like now from what I've drawn, it looks like the graph is perfect, but we still have to just like verify everything that, okay, they're saying for this region, they're saying where you're having x being less than 2, which is going to be this, which region, between this region going there, it is going to be it is going to be what? It is going to be increasing. It is going to be increasing. Are we having an increasing graph? And indeed we're having an increasing graph up to this point. But then they're saying where we are having x being greater than 2, it is going to be decreasing. Is it decreasing? You can see it is indeed decreasing, then that means we're done with that one. Then they're saying between 0 and 1, between 0 and 1, we're going to be having a graph that is concave up. Are we having something like that? Yeah, we do. We have only half of this. It's like this. We've only took this portion since it's increasing. Remember here we have increasing part and the decreasing part. Since it's increasing, then it's there. You see? So we're done with that one. They're saying now it has to be less than 0 in which region, where x is less than, oh yeah, I'm basically just repeating myself. In this region here, it is just going to be concave down, and you can see concave down, we only took it like that. So now they're saying where you're having x being greater than 1, it is still going to be concave down like this. So we only took this portion, so it's going to be something which looks like that. And that's basically how you draw your graph using your properties. So I'll try and look for another example that we're going to do in part 2. And yeah, as usual, if you do find these videos helpful, you can subscribe, and yeah, you'll just get notified when I drop more similar content like this on calculus.